What's up everybody, this is Cakez, and this time we're going to make our game run on Linux. Now, since I don't have a Linux system myself, I'm going to use VMware, the workstation player. You just have to download it for free. Then go to downloads here, and then at the very bottom, if you're on Windows and want to try this out, it is the Windows 64-bit operating systems player. Download now. I will put the link in the description, and then you need to install the system, and once you are done, you have this right here. You can then start this, and then it will give you this window minus these two Ubuntu versions. You will have to then add a new virtual machine. You can download it on this website here, the download desktop. I'll put both links in the description, and then you download it right here. This will then give you an ISO file, which is the one that I already have. And once it's done downloading, you can then locate it in your downloads folder or wherever you download it and select it. Once you have it selected, you can then do next, fill in your data and then hit next. I'm gonna call mine YouTube so I know which one we're talking about, and then hit next. The default maximum disk size of 20 GB should be fine. We're not going to use it for much, or at least I don't. And then hit next again, and then hit next again. Finish. You can then go through the setup. I have a German keyboard. I leave everything on default and hit continue on this one, and then I click install now on the next window and continue on this one. This is basically warning me about the changes, about the partitions it's going to use. Then we do continue on this one too. Where are we? I'm in Berlin. I want to log in automatically, and I just filled in some random data. Continue, and then we have to wait for Ubuntu to install. Now once you're finally done installing, restart now and we should be good. Okay, I'm going to skip through most of this stuff here. Next, blah 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 blah. Good. Now, the first thing is we need to open Firefox and get a link to our repository. We can also quickly check if we have Git terminal. We're going to open that and then we do Git. We do not have Git, but we can install that. Okay, now that we have Git, we should be able to open the browser. Okay, then once you are finally logged into Git, we need to actually get the SSH version, which means we have to generate another SSH key. So following my own example, we need to do the SSH key generation. I'm just going to copy the below example, the SSH key gen, and I'm going to change my email. I've just generated the key and then cleared the entire terminal. Now we should be able to cat that from the .ssh folder. All right, now that we have copied this, then we go into the settings right here, into the section SSH and GPG keys, and then we add in a new SSH key. And we call that, I'm gonna call this Ubuntu YouTube. Now that we have this, we copy the SSH key of the repository, and then we clone our repository, and it looks like it works, yes. And once it's done, we should be able to switch into Celeste clone. It looks like it does work, which is very cool. Now I'm assuming I don't have Visual Studio Code. No, I don't, which means we have to install Visual Studio Code next. I'm just going to use the browser for this. I think it's DEB. Software install, and then we open. Then it's going to give us this window and we are installing, and I guess it asks us for the password again, which is fine. We enter that. Once it's done, it should look something like this. Now we should also be able to go in here into the Celeste clone and call code. Dot. And this time it opens up Visual Studio Code. And this is the time where I guess trust, yes. I'm going to install the same extensions again. And this time I'm going to tell you that Vim, use it with caution, because Vim changes the way you input text into the editor. It is a somewhat confusing text editor. And if you don't know what this is, you probably shouldn't use it. Then I'm going to use the Microsoft C++ extension and then the shader language support. At the end we have C++ shader language support, and for the ones that know what it is, Vim. Okay, cool. And now we can already start to look at our first C++ file, which is the main CPP file. The first thing would be to make it actually run. And in order to do that, we need to change the launch and tasks.json. The launch.json now has two configurations. We have a Linux launch option and a Windows launch option. The difference between the Linux and the Windows one is basically the type and the name, of course. And then on Windows, we have this integrated terminal option that we don't have on Linux. Actually, it doesn't exist. Or it doesn't exist in this type of configuration. And then the tasks.json is almost the same. The only difference is that we now have a Windows and a Linux branch. On Windows, we still do the sh build.sh, and on Linux, we do the ./build.sh because it's natively supported. And this is where the first hurdle will come into play. If we now go and call that, it will give us a permission denied. So we have to actually turn this sh file into an executable file and tell Linux that actually we can execute this file. We do this with the change mod command. Then we add the executable option to the build.sh. I wonder if I'm explaining this to no one. But I'm still going to explain this just for completeness sakes. I'm pretty sure that most of you already know what all of this does. Alright, now it is executing our build file, but obviously it's trying to build for Windows, which doesn't exist at all, right? So we don't have anything building for Windows. And at this point, we can change the build.sh file to accommodate Windows and Linux. So essentially, we're going to clean all of this up. The way this will work, I'm going to give you a general overview. We will have the finds at the top and warnings and the includes. All of those are platform agnostic. And then further down below, the compile command for the game is not platform agnostic, but specific. But the compile command for the engine is almost. We're going to change this, but I'm just going to copy in the entire file. And this is what it looks like now. We still have our defines, warnings and includes at the top, but now we actually differentiate between Linux and Windows. So for example, if our name, uname, and this seems to be some sort of inbound variable, is Linux, then we are running on Linux. And we want to load in the libs x11, OpenGL, and FreeType. This is for Windows, opening Windows, not Windows, OpenGL and FreeType. Then our output file will be Schnitzel. There's no extension like on Windows .executable. And then we do basically almost the same thing as on Windows. We remove everything that is related to game underscore. Then we compile our game as a shared library. Then we also have the PIC option. I'm going to get to this in a minute. We basically create a shared library and then copy that over to a .so file. This is apparently the naming conventions for our shared libraries on Linux. We also have an if check for Darwin, which is Mac, which is not supported yet. The person that is currently working on Mac is making progress, but he's not done yet. And so I'm not going to cover or talk about this until he's done, and I'm not going to put him under any pressure. So it will take some time until this is finished. And then at the very bottom here, the else case is we are running on Windows. These are the 3 platforms that we're trying to support. On Windows, you should already be familiar with this. The output file is executable, and then we have the libs. This is nothing new. And then we remove all of this stuff. We build the shared library. We move the game DLL, and then at the very bottom, using the output file as an output file, you know, the one that we generate here, we build our engine. Okay, now this PIC, and if you want to read up on this, there's a decent explanation on Stack Overflow. But in general, what this does is when we load in a shared library, code needs to be part of that shared library, and code has memory addresses. It's basically just like variables or memory that you allocate in the game, but for the code. The code needs to be somewhere, you know, it takes up space in the file. And what this does is it allows us to not have fixed memory locations for the functions, but they are dynamic. They are position independent, if that makes sense. So that allows us to load in dynamic libraries. What exactly that does, I have no clue. And I don't really care, to be honest. All I know is that we need this. And if you want to do further reading, I'll link you this in the description. There's also this article right here that goes into more detail on this. I'll put also that one in the description for those of you that really want to know what it is. But we will still not be able to run this. We can do Ctrl-Shift-B. It will give us Clang++ command not found. We now need to install or get Clang. If you do the Clang++ in the terminal, you will see what you have to do. Sudo apt install Clang. If we now call the build.sh file, we get actual errors, which means we can start fixing them. We are running on Linux, and we get our first error, which means sprintf s is not defined. And since I don't want to find out which actual include that is, I'm just going to fix this one. So in the sound.header file, instead of sprintfs, I'm going to use sprintf. If you want to fix the correct include, you can do that. The next one is sleep, which means sleep is a Windows function, and that is the one that we call in main. At the very bottom here, we call sleep. That should be platform sleep, aka a platform function, which means we have to add that to our platform header file. It takes in an unsigned int and then just calls the platform specific function, which means we have to go to the Windows platform at the very bottom as well. Since we are on Linux, we still have to do it on Windows. And I just realized I didn't add in a parameter name, so switch back to the header file and supply the ms here. Sorry about that. Basically a platform sleep in the header file and then a definition in the Windows platform. If we build now, we get a bunch of no such file or directory. We need to get x11, we need to get OpenGL, and we need to get FreeType. I've done some digging on FreeType, and this command right here is going to help us. Paste. In order to get libx11, we can use this command right here, sudo apt install libx11-dev. On the OpenGL one, there's multiple ones. I'm just going to trust that you know which ones are the best ones for you. I'm going to use this one right here. If we build now, we get a bunch of undefined references. And that means we actually need to have our platform layer. In order to do that, I want you to go to the main file, and at the very top where we have our Windows platform, I want you to do some cleanup. First of all, we don't need this lookup table, and I'll show you why in a second. And then I'm going to replace it with the platform includes. Essentially what we are doing here, we check for Windows, and if we have Windows, then we include our Windows layer. If we are on Apple, then we include our Mac layer. And if we are on Linux, then we include our Linux layer. So essentially, the idea of this engine is to have one single platform file for each platform layer. And then you might have noticed these game lib names. At the very bottom, we have to change the reload game DLL function because it is no longer a game DLL that we load. It is a very specific one. On Linux, it's going to be SO, I think on Mac too, and on Windows, it's DLL. So essentially, this entire function here is going to be replaced by this function, and the only thing that actually changes is the game lib name and game load lib name everywhere, and those are being defined at the very top. Over here it is .so, and over here in the Windows one we have .dll. And then one last thing that I want you to change, otherwise it's going to cause an error. We have to fill in the lookup table after we created the window, and you will see why in a second. That has to do with the Linux layer. Going back to the reload game DLL function and then looking at the actual definition of those, we have them as const chars. And if you take a look at the functions, the platform load dynamic library, for example, in the header file of the platform, they use characters, and it is going to cause an error if we don't use a const here. So for loading the dynamic library, loading in function names, I want you to supply consts. And I want you to do that in the header file, and I also want you to do that in the Win32 platform file. Right above the lookup table we have these functions. So over here the load dynamic library, please turn that into a const character, and then also a const character for the function name. Now I think at this point it would be great if we added in the Linux layer, because otherwise we have all of these errors. So I want you to create a new file, new source file, and call that linux_platform.cpp. Now obviously this is going to be a lot. If we build now, obviously it's not gonna work. The first thing that it's going to complain is the key code lookup table, and I think it would be a good idea to now add that back in. That is in the platform layer here at the very top, and the platform globals. Now that we have this, I noticed a problem when pasting in the reload DLL. I don't know why, but this is still using the sleep. We have to use the platform sleep function like this. That should help a lot. Now when we build, we actually get errors. Copy file and read file both want character pointers, and we supply const character pointers. That one, we need to turn that into consts. So over here the copy file, turn that into consts, and then further down below we supply consts too. So we have those two consts, and then up here a read file takes in a const file path now. Obviously I could have done this before. I'm still very new to the const stuff, even though I've been programming in C++ for like 3 years. I just try to stick to C mostly. So yeah, we take in the const char everywhere, and I think we also have to do this on the get file size method here, or function. And if you want to, you can also do this in file exists. Then we have const everywhere. Great. Let me double check if we can build, and in fact we can. And let me see if I can do anything about these errors. It should be able to find those. Maybe if we restart or reload the window. It looks like reloading the window worked. Not sure why these are blue, but okay. Yeah, I take it. So the game builds, which means that this is correct. And I think it's best if we go through this Linux file one by one. Essentially what we have to do when we want to create a new platform, we take a look at the platform header file and we have to implement these functions. If we successfully implement these functions, then we should be able to run the game, because the rest of the game and the engine should be platform agnostic. That is the idea. So what do we have to do in this Linux file? The first one is we create a window, and that window creation, you can see these statics right here, is dependent on OpenGL as well. And so we're going to have the OpenGL initialization from Windows in Linux as well. But basically the way we are doing this is we are opening a display, which is this display static pointer at the top here, and then we create a simple window supplying this display as a root window and the display as the first parameter. Basically it requires a display pointer, a window, and then an int for the position, a width and a height, a border width, a border height, and a background. And you can see right here what we supply: 1010 and width and height. And then further down below we get to the pixel attributes, and this is something for OpenGL. The good thing is we don't have to create a fake window like on Windows. We have these functions. We have these functions available already, or we can get them without having to destroy our window. You know, the create context attributes function, for example. And then we also get ourselves the swap interval. But first what we have to do is we define our pixel attributes, and you should be familiar with this: double buffer, red, green, and blue size, and then none to terminate the array. And then this is something different on Linux than it is on Windows. We call glx choose frame buffer config using our display and our pixel attributes, and then we store that in our frame buffer, basically however many we have, and we get ourselves a glx frame buffer config back. What exactly all of these things mean, I am not 100% sure, because I'm not a Linux expert and you should not consult me with these things. I'm just going to show you how it's done on Linux, because I'm mostly developing on Windows. Okay, just wanted to point that out. I think it's very important to say that. So yeah, if we continue along here, we check for the frame buffer config. If we get nothing back, then obviously something went wrong and we return false. So we did not create the window properly. Otherwise, we can now get ourselves our functions. This is our context attributes function, and this is the swap interval function. You know, basically the one for vertical sync. We get those two functions, and they both call a function called glx get proc address. And then we are already able to define the context attributes, and you should be familiar with this. This is something that we had to do on Windows 2. We set the major and minor versions, 4.3. We set our profiling mask. We set the context flags that we want to have debugging as well. And then we terminate the array. And then we create the context attributes, which gives us a context back. And now we are almost done with the initialization of OpenGL on Linux. This is much more simple on Linux than it is on Windows. Very cool, right? The only thing that is left to do is to set which type of input we want to gather from our window. And I've put most of this stuff in the comments here. So basically we want to be able to look at key presses, releases, button presses, and button releases. And then we select that input using this mask on our window. Then we map the window. What exactly that does, I don't know. Again, that is the equivalent of the Windows make current for OpenGL. And then we have to set this intern atom. Basically tell the server to notify us when the Windows manager attempts to destroy the window. And then we are already done. There's not much to do when creating a window. We basically just create a simple window, which is really cool, you know. And then further down below we have the OpenGL stuff and the input gathering. Very, very nice. Without the OpenGL stuff, this would be, I don't know, this much code. And then on the update window function, this is where we actually gather the input and we generate our mouse positions the same way that we do it on Windows. So we have our window, we have our child. In order to gather our mouse position, we have to call the function xQueryPointer that takes in our window, some root and child nodes. I don't know exactly what these do, but basically we need to again generate root x, root y, x, y, and then our mask return. That's a little weird, to be honest, but essentially what this does is it gives us the mouse position in WinX and WinY. And then we can store that here, and we can also store the previous mouse position. But I think this is not needed because we are doing this in the game. There we go. We're doing this right here in our fixed update loop. This is just something that you would usually do, which is why this is left in. You know, if you don't do a fixed loop, then obviously you want to set the previous mouse position whenever you get a new one. And we also would like to set our mouse position of the world based on the screen to world or coordinates. This function actually is available, and we can also inspect this. Visual Studio Code just doesn't understand that we have access to this. That's all. Okay, now we actually get to the interesting part, which is gathering input. And in order to understand how we can gather input, it is best if we first take a look at our keycode lookup table. Because this is the reason why we have to do this keycode lookup table after we create the window, because we need access to the display. And the reason why we need access to the display is because the values for these keys are hexadecimal values, and you can see that some of these are quite high. So for example, the XK escape one is 65,000. And obviously, if we were to use this value and then index into our array, which only has 255 slots, we would out of bounds. But in order to fix this, there's this X keys to keycode mapping function, and this is basically part of the xlib header file. It takes in a display and one of these key sims. And so what we can do here is we can fill in our code table, and all of these key codes map to a value between 0 and 255, which is really cool because now we don't have to have such a big array and we still get access to all of the input that we want. And so basically that is the reason why we have to do this in the main file right here. We have to first create the window and then fill in the table. Right, now that we know how to get our key codes, we can actually talk about the update loop of the game. About the window. We have an X pending on the display. It doesn't block, which means if there's nothing in the queue, then we just continue here. This function gives us back an event, which we can get by calling xNextEvent on the display. Then this event gets filled in and we can inspect this. Basically, it is a ginormous union, and unfortunately, I can't really scroll in this. So yeah, it's really annoying to scroll, but basically it is a very big union that has button information if it is a button event. It's a bunch of events stacked on top of each other. It's a little bit convoluted in my opinion, but it works. So for example, if we have an expose event, and I think this is terrible name, but okay, in the expose part of the event, we can get the width and height, and that gives us a new screen size. So basically this is the WM size equivalence of windows. Then we can also have a key press or key release, and you should be able to understand what this does because we've already seen this on Windows. We find out if we are down or not, and then we get ourselves the key code, and we can get this key code by calling the event xkey.keycode. This one is the key code that is between 0 and 255, basically the mapping one to the X key sim to key code one. So we get ourselves a key code, and you know, then we get ourselves a key, and then we set the just pressed, just released, is down, and all of that. We set all of this. This is the exact same thing that we do on Windows. We do the same thing for button presses and releases. And then the last thing here is the client message. This is the one that we talked about earlier. If we want to delete our window, we're going to set running to false. And so that is already everything on the updating part of the window on Linux. Not that much actually. Now further down below we have our platform load GL function, and you can see that it is just a wrapper around the glx get proc address function. So nothing new here. We're just wrapping around this function, get ourselves the proc address back. If not, we assert and we return the proc address down at the bottom. The platform swap buffers, which is the one, you know, that we need to call every frame, just calls down to glx swap buffers. Unfortunately, this is not platform agnostic. Again, would have loved if it was. Platform vsync calls down to our pointer that we get in the Windows function, right? When we create our window, right here, we have to get that. Then the platform load dynamic library. In Linux, it's called dlopen, and it returns us a void pointer to a lib. I just noticed another bug here. This one is not correct. This needs to load in the DLL. Sorry about that. That actually is a DLL. We want to open the DLL, and if we are unable to do so, we can check whether there was a DLL error and then print that out. We could actually, you know, do this as an SM assert as well, like this. Then a dynamic linking error occurred. We can do this here and check the error string. And if we did, we return the library, of course. Further down below, we have the load dynamic function from a DLL. It takes in the DLL and the function name, and this is called dlsim. It also returns a void pointer to a proc address. We just assert on it. If we are not able to do so, then, you know, we get an error message. Otherwise, we return. And then the platform free dynamic library is just called DL close. Takes in a DLL. It actually is not a DLL on Linux. I still name this DLL, but yeah, then we get ourselves a free result back. We can assert on that and we return that as a boolean. I've already talked about the keycode lookup table. Let's skip past this. And then there's not actually much to do here because Linux audio is a thing in and of itself, and I haven't done that yet. So yeah, we'll get to that, I promise, at some point. I want to do this. I need this for my own engine as well. So yes, we're going to do it, but for now it is not supported, unfortunately, Sag, I know. And then at the very bottom we have the platform sleep function. Now the cool thing is that we can already compile our program, and this is what I wanted to get to at the very beginning of the tutorial. I wanted to show you a way of making a C++ engine, and I hope I achieved in that goal, where you have a somewhat platform agnostic framework. Obviously this is not perfect. It is the very baby steps of such an engine or such a framework, but I hope to, as I make my own game and as I get better at making these things and programming these things, I hope that something like this will grow, or this will grow into something much better. Mostly for myself, I want to use this to make games, especially 2D games and then 3D games in the future as well. But yeah, enough blabbering. If we run the program now, we actually get a problem. We're going to get an OpenGL error, and the OpenGL error that we get in the terminal tells us that our program is not linked. And unfortunately, we do not get this error on Windows, which I find very sad. Essentially, the reason why it's not linked is being told to us when we check for the link status of the program the first time we create it. And again, please ignore these squirrely lines because these things exist, otherwise the program would not compile. Essentially right here where we create the program and then link it, what we can do is we can validate if the program works. And if we then build this again and run, then we get a different error. Basically what this is telling us is that the vertex shader output specifies a non-interpolation qualifier, but the fragment shader specifies a flat interpolation qualifier. And I wasn't even aware of this error because I never got this error when I was programming in Vulkan. Essentially what this error means is in the fragment shader we supply these flat options, which basically means no interpolation please. In the vertex shader when we output them, we don't. And apparently, at least on this Linux system with this configuration, that is a problem. If we supply these flat options and then run the program again, the error should no longer happen. Apparently, since me catching this bug, which you know was the .dll here, it's a little bit weird. We have to specify this / and you might remember me doing the DLL right here or putting the DLL right here. What we actually have to do, or you know, this is a band-aid fix, but I've added in sprintf into the path using the / at the very front and then DLL opening that path. This will allow us to open the path properly. Now I'll think about a better solution. I don't have one right now. It's a little bit weird. If you guys have a cool idea in the comments, feel free to let me know. But if we are able to do this now and then build, we should be able to run. And yes, we are. Which means we are running the game on Linux that we can resize and do cool stuff with. Now you might have noticed, let's close this and open this again real quick, that Celeste falls and runs very slowly, and that is the reason the last time in the game.h file I changed to 30 FPS and I didn't change it back. So if you want to run the game normally, you should change that back to 60. Now we have the game running normally and on Linux. Quickly checking on the Windows side of things just to make sure that everything works. There's a platform would be the correct one, and then it should also build on Windows. And just a quick check, obviously now it's complaining about the launch one. It's trying to launch Windows. Actually it's trying to launch Linux. We obviously want to launch Windows. Unable to start program. I found a solution to the dumb error. It is adding an executable here, which I find weird because now that runs. There you go. But I have another program that is literally exactly the same right here. And you can see that I don't have an executable here, right? if I just go into the launch.json here, nothing. I use the Windows launch option. If we go over here, Windows launch is selected and I press running and it gives me the same. Yeah, Visual Studio Code, ladies and gentlemen, at its best, finest, best of its abilities, perfectly stable and works always. Anyways, just wanted to rant a little bit because it's not the first time that stuff like this happens. So yeah, this was the Linux platform. I hope you enjoyed this tutorial, and if you did, please leave a like and subscribe. It really does mean a lot to me. It takes a lot of time to make these tutorials, and that is a great way to support me. And yeah, I hope to see you in the next one. That will be a lot of cleanup or some cleanup, making wall jumping happening, but mostly we are done with the tutorial. We are very far at the end and there's not much left to do. So if you've gotten to this point, I really appreciate it. Thank you for the support and sticking till the very end. I know this is very technical stuff, which is not that fun or interesting, but I still think it is very important for those that really want to know, okay, well, how could I potentially do an engine from very scratch myself in C++? And yeah, I hope you enjoyed this. I'm very happy that I did this. This is something that I was missing when I started out doing C++ coding. And yeah, I hope you enjoyed it again. Until then, see ya. Peace.